In lesson 4 of chapter 6, education, we're going to look at the education as a signal model. In it, we're going to consider a simplified labor economics model where individuals make decisions about investing in education as a signal of their productivity in the labor market. In this model, education serves as a signal rather than strictly as human capital accumulation. Assume there are two types of workers: kinesthetic learners and academic learners. Academic learners are type A. Kinesthetic learners are type K. Type A workers have a knack for doing work that is best learned in university. Type K workers have a knack for work that is best learned elsewhere, and their true productivity cannot be observed by employers. Since the true productivity of workers cannot be observed by employers in industries needing skills taught in universities, type A jobs, these employers use college degrees as a signal of future worker productivity in type A jobs. The present value of lifetime earnings for type A jobs has to be such that the difference between it and the present value of lifetime earnings of jobs in industries needing skills not taught in universities, type K jobs, is enough to entice just enough workers to seek college degrees. If the lifetime earnings of type K jobs equals $350,000 and the lifetime earnings of type A jobs equals $456,000, the compensating wage differential is their difference. So we're going to take their difference, 456 and 350, and we get 106, right? $106,000 is the wage differential. And now when I hit enter, after entering this number, $106,000, I get a height at 456. This is $456,000. I get that in both graphs. I also get the $350,000 in both graphs, right? Now, the cost of higher education, C, is considered to be linear in the number of years spent in education for both low and high productivity workers. The high productivity workers are the workers that have a college degree as a signal that they are a high productivity worker, right? The workers that don't have the college degree are signaling they're low productivity workers in these type A jobs, right? In these type A jobs. Let the cost of attaining this education by both types of workers be given the functions below. So K-type workers, this is the number of years of education for them, and this is the cost. Now, because a type K worker is not very good at the tasks that are needed, the skills that are needed to acquire a college degree, maybe it takes them a little longer to do it, right? And one way to do that, or maybe they have to work extra hard. They have, instead of studying 20 hours a week, they have to study 40 hours a week, right? And time is money, right? So we're just assuming that the slope of this line with the intercept of 0 is 30, right? So each additional year of college costs this worker 30, right? $30,000. For type A workers, additional year of college costs them $23,000, right? Why? Well, maybe the type A workers get scholarships, or maybe they find the work easy and don't have to work very hard at it, right? And therefore don't have to spend any money on tutors, right? So the cost of acquiring education for the type A workers is lower than it is for the type K workers, right? High school graduate Kevin is a type K worker, and high school graduate Amira is a type A worker. Point O in the graph on the left represents the amount of money Kevin spends on schooling if 0 years of education were chosen. The same goes for Myra at point O in the right. I think we're talking about right here, right? If both choose 0 years of college education, Kevin and Amira will both spend, well, if we plug 0 into here, right? If we plug 0 into this E in either one of these, both will spend $0, right? Both will spend $0. And this is the point O we were talking about. Now, if both chooses 1 year of college education, right? I'm going to plug 1 into here. 1 times 30 is 30. So Kevin's going to spend $30,000. And Amira will spend $23,000. If both choose 2 years of college education, neither one has acquired the signal yet, right? So both are viewed by employers as type K workers. They're not viewed as type A workers until they've acquired that signal, right? So if both choose 2 years of college, so 2 times 30, this is 2 here. 2 times 30 is $60,000 for Kevin. And Amira will 2 times 23, well, that's $46,000, right? Again, maybe Amira is getting scholarships and doesn't have to pay for tutoring. Kevin doesn't qualify for the scholarships and is paying for tutoring. So it's costing him more money, right? Neither one have yet to acquire the signal, right? They haven't graduated yet. So they're still considered type K workers, both of them. If both choose 3 years of education, Kevin will spend what? $90,000 trying to get that college degree. Well, trying to get those 3 years of college. Amar will spend 23 more to 46, right? So 69. We're just adding 23 onto the 46, right? Okay, so neither has acquired that signal yet, right? If both choose 4 years of college education, Kevin will spend $120,000, right? And Amara will spend, we got to add 23 to this, right? So 3 and 9 is 2. Carry the 1. 2 and 6 is 8. Plus the carried 1 is 9. So $92,000, right? Okay. So this is from this red dot to here is $92,000. From this red dot to here, that height difference is $120,000, right? Now, if there are thousands of type A and thousands of type K workers, how many of them will go to college for 1 to 3 years? 0, right? 0 aren't going to go, because why would they go? You want to go to college to get that college degree, to send a signal to an employer that you're going to be a high productivity worker in a type A industry, right? So neither the type A nor the type K workers will get some college. They're going to go to college to get that college degree, right? No, so Kevin must spend a total of $120,000 to earn a college degree, right? Subtracting that from the compensating wage differential equals what? So I'm gonna put this over here, and I got Kevin, and I got Myra, and Kevin. We're gonna subtract the $120,000 that Kevin spends on a college degree from the $106,000 compensating wage differential, right? And that's 14, right? 14. Thus, college is too expensive for Kevin. And Kevin chooses 0 years of education. I guess it wants me to take the compensating wage differential and subtract off the 120,000, right? So let's resubmit that. Okay, subtracting that from the compensating wage differential. So it would be negative, right? Now, Myra must spend a total of what? She's spending a total of $92,000 for a college degree. Subtracting that from the compensating wage differential is $14,000. Thus, college is not too expensive for Amira, and she chooses 4 years of university schooling. And that puts her solution here. Whereas Kevin's solution is there. He chooses 0 years of education.